introduction to biorefinery, engineered microbes for cellulosic ethanol, co-fermentation of glucose and xylose. So I now invite Dr. Howley to kindly take over and start with the tutorial. Sir, please.
Okay, also upload the next one. Okay, this afternoon I would like to share my research methods with you, including the biomass pretreatment and the medical hydrolysis and the fermentation method. In the last part, we will finish the discussion about my questions in the last two lectures. Let's go to the biomass pretreatment first. This morning, we discussed the feedstocks, which feedstock we should choose. For example, if we choose the rice straw, if we choose the wood chips, what's the difference? What's the difference? Density, right? The solid density is totally different. Okay, if we have a truck and you filling the truck with rice straw and always the chips, which feedstock, the total amount you will get. Definitely it's wood chips because it has very high density. And if we use bamboo chips, okay, the total weight will be higher, right? Before we do the pretreatment, we have to take into consideration, okay, what's your machine, what's your instrument? Usually we use a machine like this. It's a rotary spheric digester. And this one is a vertical digester. They are different, totally different. Okay. If we choose this one, the rice straw is fine. We'll fill in this bowl, the rice straws, and we can also fill it in the wood chips. It's also okay. We will use a pressure. We use a lot of methods to fill it in with the biomass and reduce the content of gases inside. Okay. But for wood chips, we have to. For wood, we have to cut it into chips, right? We use a very convenient machine like this. Right? The efficiency is very high. I visited in Germany. They have a lot of very short trees. In the autumn or winter seasons, they cut it down and process it, cut it into chips like this. It's very convenient. So for the wood chips, we have to cut it into define the size. The thickness is usually 10, and length and width is usually 30 centimeter. And for the rice straw, it's better for us to cut it into small pieces, but not easy. Not easy. And there will be a lot of dust. It will contaminate the gas. So the first thing is size, and then next is the moisture content. Because if it is wet, okay, we load a ton of the raw material, but the moisture content is 50%. So actually, its dryness is only 500 kilograms, right? So we have to test the moisture content. So we usually test the moisture content for a series of procedures. We have a Chinese national standard. We also use sometimes we use standards from US, established by US. The NVL procedure is very good, very suitable for us to do the biorefinery. Do anyone know how to test the moisture content? How can we test the moisture content? We use an oven, dry oven, right?
Initially the weight man.
Yes, we initially the weight. Yeah. But however, if there are a lot of wood chips, how can we take the samples? Yeah. How can we take the sample?
There's a machine also.
There's a machine, yeah. There should be sensor, right? And but the surface, the moisture on the surface and moisture inside are different. The value is different. So how can we test it? So we have a conveyor. It transfers the wood chips into the digester. During the transportation, we have some sensor to test the moisture. And the data is not stable, but we can calculate it, right? We can get average data, average moisture content. Another important parameter we have to get to know is the glucose silane lignin content, right? The glucose content little higher than the cellulose content because there are some glucose unit in the hemicellulose components. So we have to test the three major components. How can we do that? We have to first do separation. We use sulfuric acid, right? Yeah, hydrolysis. Yeah, we use acid hydrolysis to remove glucose and xylene and lignin. Class lignin is there. Okay. Then we do the class lignin, and we test the components of the monosugars in the hydrolysis. We know final content of the glucose and xylene. It's not liquid. Then we are going to test the ash. The ash is not important for wood. It's not important, but it's very important for straws. Usually, the ash content accounts for 3 to 5% of the total weight. In particular, for bamboo, I made the bamboo material. The ash content is as high as 9%, very high. And the extractives content. Extractives. These extractives content is not high in wood, but very high in straw. Okay. Then we will do some prediction from the content data. We will get to know the cellulosic ethanol production from all of these feedstocks. Then we can subject these materials to the pretreatment. Pretreatment is the next step. Okay, we have two choices. One choice is spherical and spherical machine. This machine is heated by steam. Okay, the pressure and the steam, the temperature, they have a relationship. We can measure the pressure and get to know the inner temperature. However, the temperature sometimes the pressure is not uniform. not uniform. And this machine is different. We do not heat it directly. We use a heat exchanger. Heat exchanger means the wood chips were loaded, is loaded into this tank, and there is a screen. For each cycle, the liquor separated with the solids, and the liquor is recycled from bottom to up, and passed through the heat exchanger. It is heated here. The liquor is heated here, and the liquor is circulating. Then the mass transport is better. Okay, it's better. But this one does not need a heat exchanger. It rotates to realize mass transport. In addition to biomass, we have to load the chemicals to digest the biomass. For corn store, most commonly we use the chemical is sulfuric acid. We use sulfuric acid. It's enough at high temperature, 170 degrees centigrade for nearly 10 minutes. But if we use another procedure, we use acidic sulfide. We use sodium bisulfide. This chemical is very special. It delignifies. It removes lignin by sulfonation. Sulfonation effect. Okay, if we use this method, we will get totally around 30% of lignin removed, and almost all the hemicellulosic sugars are removed. So the cellulose content can be enriched and to a very high level.
The percentage of sulfuric acid.
What's percentage? For the dilute acid, usually 1% to 1.5%. For this, usually 1%. So we also need water. Water is also important. For wood chips, the ratio of water and the biomass is usually 3 to 4. But for the straw, 4 is not enough, right? Maybe 8, maybe 10. It means if we do the pretreatment in the spray machine, okay? If we use a dry straw, the major component in this machine is not biomass, is water. We are heating up water. Am I right? But if we use wood chips, it's better because the amount of water is much lower.
What's the benefit of rotating it? Steam cans. Steam can still has the
Yes,
rotates.
It has liquor, it has chemicals and liquor. It has some liquor. So rotation is sometimes helps the mass transport. But the speed is very slow, very slow. And the straws and the gas cannot be used in this machine because you will see it. Yeah, the tube is narrow. The diameter is very small.
So what is the biomass loading for the total solid loading? Solid loading.
Sorry, I cannot
How
get.
much percentage of solid is added?
How much percentage of solid?
No, whether it is the gas or straw. Solid loading percentage.
Usually,
Isn't your question clear to me?
It's 10% solid with
10%, yes, 10%.
10%.
10%. For bagasse, the water, the ratio of water and the biomass is 8 to 10.
That is the consistency. Consistency.
Consistency, yeah.
We call it consistency.
10 to 12. Yeah, 10 to 12. Consistency.
And particles and particular substrate.
Particular substrate.
What is the particle size
What's the particular size
of substrate?
of substrate? I mean, before pretreatment,
Yes.
before pretreatment, if we use bagasse, we do not do the size reduction. But if we use straw, we have to do that. because the entrance is narrow.
Yes.
Entrance is narrow. It's not smooth. After cooking, we generally call this process as cooking. After cooking, we do the mechanical size reduction. The mechanical size reduction we usually use this machine. This machine depends on the rotation of two discs in opposite direction. This machine is highly developed. Okay, it can defabricate the biomass into very small particles, like fiber, like a power people making use of fiber.
These are plates,
Yeah, plates.
or it crushes it.
Yes. It also breaks down the middle banana between two plant cells. It's yeah.
This is a patented technology or it's a regular procedure? Patent, we do have a patent on all these, this fabrication procedure.
Yeah, we publish them. We
Published or
in many publications we use this technology.
Oh.
We use these machines. Okay, next is about enzymatic hydrolysis. In my lab, I do not produce cellulose by myself because I have a better choice. I use non-time products or products from other Chinese companies. When I get the cellulose, I will do the dilution first. I dilute it into a series of concentration dilution method. Then I will test the activity. Usually, we test the filter paper activity, right? We also test the activity. And how can we know the activity?
So it is in
Yeah, we just DNS. Yeah, DNS reagent to react with reducing sugar, and we know the activity.
So what is the maximum FPU for this enzyme? What is
Maximum
FPU, pretreatment activity?
maximum.
How much units does it?
How much units? In China, the CTAC2 is around 150 FPU
Per ml?
50 FPU
per million. Per million.
Per ml.
Per million. But I usually use per gram. Its gravity is not 1, it's 1.2. 1.2. Gravity higher than water, density higher than water.
This Novozyme must be supplying free of cost or as sample or you're buying it?
We purchase it. But the non-science companies, they usually sell their products in very huge quantity. For example, 500 kilograms. So,
This one is not Novozyme, this is Chinese.
no, this is from non-science.
Novozyme.
Yeah.
So you, China is import.
I have 500 non-science CTAC2 in my lab.
CTAC2
Uh,
can or CTAC3. So Novozyme enzyme is CTAC2 or 3?
I don't know. This picture is not from my lab. I get it because I get it.
Because nowadays CTAC2 is not recommended. People are using CTAC3 and HTAC3.
Okay. But mostly we use liquid enzyme. We do not use the solid anymore. Although solid cellulose can be preserved for longer time, but the liquid is favorable. And about another enzyme, which is beta-glucosidase. Beta-glucosidase degrades cellulose into two glucose molecules. In the lab, we use a special chemical, is PMPG. I purchased it from Sigma, and follow this procedure to test its activity. It can cause the signals in the photometer at a wavelength number 405 nanometer. The method is not difficult.
This essay is an extensive one.
Yeah.
As it is.
As we prepare the biomass and the cellulose, we also need to prepare buffer. Buffer is very simple. Okay, that is subject them into a hydrolysis container. In the lab, we use the flask. And flask is simple, is very good for research. We also use a blank tank. But for high solid consistency, I would like to use this machine. This machine is is for flour mixing machine. It is very convenient to blend the biomass slurry with very little amount of water. After that, maybe after 2 days or 3 days, we will collect the hydrolysis products, especially glucose, mainly glucose. We have two ways to
Sorry,
detect the
I
glucose.
forgot that. Why do you need to make that dough on the in the previous slide?
Well,
Machine, you showed that.
This one,
Yeah.
Yeah.
What's the use of
Okay.
having such a high consistency? You're doing enzymatic hydrolysis at such a high consistency.
this one.
Yeah.
We tried.
This machine you're using for making cell,
Cellulose, yes.
yeah.
But it is this machine is commercially used for flour mixing.
Yeah, but it has,
I use it to mix the cellulose and the biomass.
so what percentage of biomass do you use in this machine?
30,
30.
30 to 35. That's
Okay, that makes sense. Yes.
no water at all.
30.
No free water. Yeah. If you press it,
But the enzyme diffuses, like, does it hinders the diffusion coefficient of the enzyme also? Like, the enzyme cannot diffuse through the biomass. It
yes.
won't
So
hydrolyze.
we need a very strong blending.
Okay.
Am I right?
So that is motor driven, like,
This is horizontal, actually, for enzymatic calculation also go to horizontal reactor instead of vertical reactor. That also increases the efficiency of the enzyme. This is working on horizontal.
Yes.
Yeah, very good actually.
In the publication, in literature, there are a lot of design of the special machine for high solid hydrolysis. This one I tried. Others I do not have. Others.
How much time it takes for sacrification?
120 hours.
100 hours.
Yes.
So this was shown for 100 hours, moving for 100 hours.
Yeah.
Temperature,
Uh-huh.
at what temperature?
What temperature? Temperature usually 40 degrees centigrade. 40 to 45.
This is the optimum temperature of the enzyme.
Optimum is 50. 50 for its optimal activity.
Then say you didn't write it at 50, why at 40 to 45 only? If optimum is at 50,
Yeah.
yeah, there's no provision to maintain temperature.
yeah, maybe. It looks like a water bath experiment. Water bath experiment.
Yes. For the detection of glucose from hydrolysis slurry, we have used two methods. The first method is based on the glucose oxidase and peroxidase. Okay, this one oxidizes glucose to gluconic acid and one molecule of hydrogen peroxide. Hydrogen peroxide can be catalyzed by this one, and there is a dye to indicate the amount of hydrogen peroxide generation. So in my lab, I have this machine. I purchased the one. This machine is it's biochemical analyzer. It's very convenient. It depends on the immobilized GOD. It does not rely on the HRP. It has used immobilized GOD to detect the content of glucose, but we have to dilute the hydrolysis slurry. And this one is glucose analysis kit. It's usually we use spectrophotometer to test to detect the absorbance. And we also have a method use HPLC. HPLC is also good, but very slow. So usually 30 minutes, 30 to 40 minutes to get one data. It's slow.
For second one, how much time is required?
Use this one 2 minutes.
2 minutes.
Use this one 10 minutes.
It's the concentration. This is a very good machine.
Yeah.
Straight away you get 12%, 10%, 9%. Just the probe which steps in.
So this instrument made in China or made in US?
Made in Canada.
Canada.
Yeah, Canada. It is very popular in hospital.
Okay.
Yeah, it is used for biochemical tests.
Yeah. It can test a lot of different sugars, like such as xylose, and mannose, and ethanol. It can also be used to test ethanol content.
So the probe is replaceable in that instrument. That the back end, the probe has to be replaced, or all of the works like for analyzing the sugar in this instrument.
Is it this machine?
Yeah.
We have a small tube, plastic tube. Okay, we place 0.5 milliliter, but it should be such a filter, no solid. Okay. Then in this machine, there will be yeah.
My question is that
Yeah,
how much can the probe be used?
20 microliters. 20 microliters, a very small amount. And the reproducibility of the data is very good. The error is not very high. Usually within 5%.
It's also we need to prepare a calibration curve
No,
for the second one, or directly you get the reading that's
when we open this machine, it automatically calibrated.
But
Automatically.
how would we come to the specific direction?
We have standard.
Yeah, standard.
Yes, and even the buffer, the standard was supplied by by Canada.
So you do ready-made standards, or you prepare standards in your lab for this?
Sometimes, but sometimes the glucose will change at bottom. Right.
Actually, the best purpose of this machine is to do online monitoring during fermentation of fermentation.
Yeah.
If I do some fermentation, we need some online monitoring because you don't have to go for a cancer free every time.
Yeah.
So this is connected through your bioreactor. So this is the main purpose. Otherwise, students prefer a non-linear factor, which is not cheap. Well, the instrument is like cost efficient.
Sophisticated.
Yeah, but it's a one-time investment for online monitoring on computers, and it has some chip. It's a cheap based and low waste, basically. So you can remove the different flows, you can use different flows for different sugars, and even for ethanol also. So this is basically for online
All
monitoring.
the fermentation metabolites can be
Actually,
estimated in a single machine.
there is a present industry. Because they have to monitor the ethanol production and how much sugar is consumed hour by hour.
Yeah.
So they have to keep record, and this graphic comes from one system. So control for system, common system.
And for this machine, the glucose oxide base membrane is costly.
Yeah.
It's costly. We cannot produce it by ourselves. We have to purchase it overseas. So I always taught my students to use this method. So the company
That is cheaper. It's very common.
So in the fermentation stage, I would like to use the angel. Have you heard of the angel? Angel is
So the Chinese brand. It looks like the Chinese brand.
yes, it's in China.
This is economics only.
Yes, I can answer on it. Yeah. It's dry active. Yes,
Right.
dry. So it's active.
And the cost is less than 80 yuans.
Yeah. It's not expensive.
800 rupees.
So I do not produce
per kg.
the yeast by myself. I use this one.
Expensive.
It is not. For them, it is not expensive. Or else
It can stay under a very high sugar content.
Tolerant also.
Yes.
This is optimal fermentation temperature. It's temperature tolerance.
We have informed him in advance, he must have brought windows.
But before you use it, we need to mix it with water for 1 to 2 hours. We let because of its not dry. So what's your method? Yeah.
Yeah, we prepare the seed culture. Like we also use our own strains.
On one stream.
We steam it through.
We get this yeast powder from the market. But now we are also using the yeast which is used for bread preparation by bakeries. For practical purpose we use it. For research purpose we can try this type of thing.
Okay.
We are maintaining 4 or 5 different kinds of yeast.
Yes.
Candida, Saccharomyces we have. And there are 2-3 more strains we recently procured from IR.
Yeah, we have like Canada Shiatic, Picasolin,
Here also, right?
Picasolin and Picia, and more like. But you might be having different strain for your hexose and pentose sugars, isn't it? Because your raw material, when it will be separated, simplified, you get both hexose and pentose. Hexose and pentose and hexose.
Yeah.
So this is for hexose.
Is this for glucose?
Glucose, yeah.
Not for xylose. Because this is the non-ferment xylose.
This is for xylose,
Not for
not for
xylose.
xylose.
So what I was for xylose, we generally use a liquid one.
Yeah. These are all native strains.
Yeah, this scholarship supply.
This one conditioning is wrong.
But it is said that you want to cross the critical limit of fermentation. If you want to cross the critical limit of fermentation,
Okay.
then people have done a lot of metabolic engineering.
Camera? Yes.
Because otherwise you can't transform, you can't convert more than 50, 45, 48% I think.
Yes.
It's approx 48%.
Yes.
So are you planning for some strain which can convert more than 55% at least, because that will add to the cost. The production will be much cheaper than.
Actually, Dr. Puniti is working on this topic for me. We are constructing the list that expressing cellulase, pharmacellulase. Not very successful. It maybe requires a long time. I will introduce the metabolic engineering of the protein yeast maybe in next lectures. We have a number of different kind of fermentation machine. In the lab, I usually use this. Because it produces carbon dioxide, there will be a pressure. And about the ethanol detection, we can also use the biochemical analyzer. It's based on the membrane of alcohol hydrolysis. We can also use the HPLC, but it's very slow, very slow. Usually 10 minutes or 25 minutes. I developed a new technology with its name is gas fermenter. But we add a headspace. Because ethanol is not in organic solvent, ethanol is in water. So the conventional GC is not suitable. We use headspace. In the headspace here, there is an oven. In the oven, the temperature is very high. And that's all the water and the ethanol. Okay, evaporates. And then we use the adjuvant GC to detect the contaminant of ethanol. Very fast. In a few minutes, 1 to 3 minutes, we can test the ethanol acetone and butanol simultaneously.
How is this HSGC different from simple GC? Special feature in white space GC.
This part is GC. This part is headspace. There's a connection.
But
The sample is very tiny. Usually 5 microliter.
3 to 5.
It should be reference 4.
That also volatile to whatever components are
What
there.
you're saying, it is concentrated. So get your sample, the amount of ethanol might not be that much, which can be fetched to GC. So I think this HTS concentrate ethanol or
Yeah, concentrate.
concentrate so that you can you water it, you lost and you have more of it. But that
More
was
sensitive to simple GC.
no, it's
Much more.
one addition, it's a attachment which further increase the concentration of your ethanol in the crop. Maybe the GC you have, and otherwise you have to load more volume in the GC. There is less,
Very less
less volume
volume.
because it concentrate more. What you want to say?
This paper was published 4 years ago. One of my master students finished this work. It's very fast and very convenient. Can we come to the discussion after these questions? Yes, we have, can I sit here?
Yeah, please. Anytime you can sit, okay, and you can stand as per your wish.
So now this panel is open for discussion and if you have any query, you can ask to the student.
So for the first question, now it is very difficult to ascertain fermentation loss with 10% ethanol content. In the year 2016, one research group they accomplished this ethanol content. They published a paper. They published the paper in the journal EES. EES has an impact factor of 30, yeah, very high. So this technology is difficult to accomplish. You have your own opinion.
Yeah, please be free. You can discuss techniques, anything if you are working on that. Yes.
To this, if this is hindering your view, I think it's
First, why we ask for 10%? 10%. Because of the ethanol distillation, we use absolute ethanol for biofuel. We cannot use 10% ethanol for biofuel. There cannot be water. For the distillation of ethanol in water solution, okay, we have to use heat, right? It consumes energy. So if it is 1%, it means, okay, if it's 10%, 1 part ethanol and 9 parts water. If it's 1%, 1 part ethanol, 99 parts water. Totally different. So it's from 27 for this purpose. But why is this difficult?
Yeah, why 10%? It's very tough to produce.
does it ethanol affects the viability of the does it affects?
Product inhibition is also.
So that is one reason.
Yes.
Product.
They must be completely soluble in that slurry, some part will be volatile also. So that also reduces the final concentration of ethanol.
Yes.
Basically, I think it's the tolerance of the Saccharomyces.
Yes.
That is important.
Yes, it's important. So that's why we want to choose this. We want to choose this because it tolerates not only the high temperature but also high sugar content.
Substrate, so the high will become substrate.
15% substrate means maximum 7.5%.
Yeah.
Depends on saturated ingredients.
So you're lucky to have that.
Yeah,
commercial
in my own experience, okay, why I chose this machine, this machine, because in the first step, we have to let the biomass from solid to liquid. We call it this process liquefaction. Liquefaction. You can find this term in literature. Liquefaction. Liquefaction is important for biomass ethanol production. And for liquefaction, we need a good machine for blending. But this one, the temperature cannot be precisely controlled. I cannot control the temperature. I can control only the temperature of air conditioning. So I can do that.
This is operated in batch mode or fed batch mode?
Yes, it's like, yeah, that's more.
Batch mode.
Not continuous.
Won't the yield increase if we go for fed batch mode in the third one?
Yes, previously I presented some fed batch. Fed batch, I did it using flask. I added the materials in flask. But you know, in flask we have a rotator shaping, strong shaping, 200 RPM. It's very strong. Yes, the liquefaction is not a big problem. But for this one, no. Sometimes it works. It works.
Inside this third one, there is no central shaft to uniformly mix the solution. So this
It must
third-
be. It must be.
Okay, so we have a second question. Second question is, which one do you like to choose as a feedstock for biofuels? Grains, woody waste, and seaweed.
Because just look at the lignin content, which has the highest lignin and which has if we see the lignin content, it's very easy to work with seaweed.
Yeah.
Otherwise, the availability is again a factor.
It is a big question, right? For grains, if the grain is fresh, if the rice, if the wheat is fresh, okay, it's expensive. But if it is stored for many years, it has been stored for maybe 5 years, 10 years. There are a lot of microbial contaminants, so it cannot be used for food or feed.
Competition.
Right? It's very good, right? But in another word,
The grains competes with the food product.
Yes.
It's a food for animals as well as humans.
in the industry, grains can also be used to extract the starch, and the starch is also
It's a good
a bulk material. Yeah. Especially for paper making, you know, when we use the A4 paper, that's also this. I use a smoothing paper, okay, they're also then starch. So seaweed, I think this one is very good. It's easy to break down the soil, not difficult. If I do not use enzyme, I use 2 chemicals. One chemical is sodium hydroxide. Another chemical is phosphate. Only the 2 chemicals they can break down the cell wall and let it to be turn it to be a gel slime. So I think that it is more readily to be converted into biofuels, and but you cannot get about the availability, right? Do you eat seafood in India?
No, very less.
Not much.
In coastal areas. Coastal areas. But again, collecting seaweed is costly. Harvesting is costly. In India, it is supposed to use individual waste. Individual material.
Do you have other choice, other better choice for the production of biofuels, such as waste?
There are agricultural waste like compost, food
Compost? No, not from agriculture. Agriculture we discussed.
Agriculture waste country, there are a lot of agricultural waste which farmers are burning in their fields.
Burning. Okay.
Creating greenhouse gases and
In India, also burns the agricultural waste.
the money is stop.
lot of agricultural waste are burned.
It will bring heavy air pollution.
Yeah,
Black smoke.
It's visible from the satellite.
Another problem which goes in only goes only I've read a well-known crop scientist called Tillman. He says that grasses, tall grasses, like in India we have Saccharomunja. Saccharomunja can be used. We call Saccharomunja. Saccharomunja. It has a lot of, it's like, it's from the same family, sugarcane belongs, saccharine, same genera. So it has a lot of sugar inside. Yeah.
And apart from people are using it for biogas production.
No, it is basically used for earlier to use for making natural waste and
Yeah.
farmers are using for making that.
And in the fields itself, they are installing central reactors and anaerobic digesters for biogas production. They put all the waste
Yeah.
grass in it.
That leaf portion can be used for,
Yeah, yes.
but the stem can be used for some. People are using that. It has huge amount of sugar. And it has less of lignin, but it has little bit of lignin, some silicon.
So have you ever tried to valorize the lignin, get any useful product out of lignin?
Okay. We have
Some biorefinery.
That was in second lecture.
second yes.
Second lecture. That's so right. Starting only.
It will develop technology to produce carbon fiber
Yeah.
from lignin. First we dissolve it in a solvent. Like this. This lignin is not a native lignin. We call it organelles of lignin. It derives from the acetic acid pretreatment of biomass. This pretreatment is very important in textile industry because it is used to produce dissolving powder. Dissolving powder is a replacement of cotton. In the first step, we are going to use acetic acid to remove heavy cellulose and a part of lignin. We get the organic solved lignin from acetic acid, then we dissolve it in the solvent. Then we use a special machine. Okay.
This is like lab skin or it is commercially extracted from organic solid?
It is not a pure lignin. combined with some other materials. Yes.
But it is this technology is in lab scale or it is commercially exploited for
Yes.
production of carbon fiber?
Yes.
Based
Before that, we first get a fiber. The fiber is not black color; it's yellow color, brown color. Then we put it into a furnace without oxygen. Without oxygen, everything, all of the components become carbon dioxide. So we use nitrogen to protect it. And at 700 degrees centigrade, furnace, this furnace, the fiber turns to become fiber.
Yeah, and I think you are using also this type of cellulosic material for windows of aeroplanes and all that. You are using for that.
Yeah.
Window sheets and mobile covers. You are using that.
We're trying to use it for we have our third question is immobilization of cellulose. Can you do that? Did you see some publications on this topic? Immobilization of cellulose for the production of bioethanol from farm oil. Cellulose. Can you do that? So cellulose is different, sometimes different from other enzymes. It's progressively moves. It has a binding domain. This binding domain directs the motivation of the enzyme along the cellulose substrate. If we immobilize it, and cellulose is insoluble. So it can do nothing. But if cellulose is dissolved in liquid, in water, can we do that?
Cellulose is an enzyme, cellulase, which dissolves, is immobilized, and the substrate is not satisfied, so liquid.
So we're talking about the immobilization.
Cellulase work or not? Because it is immobilized and the substrate is solid. If it is satisfied, if it is liquid, then it will work better. It's like this, because the immobilized cellulase is immobilized, it is bound to some matrix, substrate. So which one is better? How it will work?
Has anyone ever performed research about immobilization?
Immobilization of cellulases.
No, not for cellulose, but for other, anything.
Yes, they do. Students from our department, they do.
Because this immobilization method is just for the use of enzyme,
Exactly.
so that it can be further used for setting phases.
There's one component, it's a beta glucosidase. Beta glucosidase it breaks down the cellulose to glucose. Cellulose is dissolved, totally dissolved. Okay, so immobilization of beta glucosidase is okay, it's fine. Do you think so? How do you think so? It's okay, yeah. Many researchers
to give agitation.
Yeah.
If it is because the diffusional restrictions would be there, so the enzyme and it might not come in contact with the substrate in a better way. I think free enzyme would act better. than the-
I think after internalization, the efficiency of enzyme is also compromised.
What you suggest us, because I think immobilization of any enzyme, okay, it is possible and people are doing. Especially for bioethanol, the benefits might be there because the immobilized enzymes will be targeted enzyme, exact enzyme. It will definitely be more beneficial. But we have not used immobilized enzyme for bioethanol. So I think you can throw light on that aspect. If you are using it.
After application, there is need to then harvest
Yes.
again reuse the enzyme. So that will be another challenge. How to
I think the
recycle
mobilization is important for the bioethanol.
It is important.
Because it is really be recycled, be used for many times.
Okay.
If the cellulose recycles, the cost, the economic cost will decrease significantly. Nowadays in China, we produce 1 ton of absolute ethanol. The total cost is 7,000 Chinese yuan. 7,000 Chinese yuan.
Okay.
It's about $1,000 US. And the inbound cost is $300 US in China. So if we can save this money, the price, the cost of ethanol will be significantly decreased.
So on which substrate it is immobilized?
On each substrate, based on the use of bagasse.
which substrate is immobilized, which matters.
Which matrix?
Matrix.
I don't know. I do not. Did not do any research about the immobilization. I don't know how to do that. But I think it's important. It may be useful.
Yeah, it is useful.
At least the better glucosides immobilization is not a big problem. But I don't know. Because there are a lot of solid values in the scenario.
Did you use immobilized celluloses? You are using it.
I do not use it.
You don't use it. But other people they are using it. In other universities and research centers.
I've read several papers.
Okay.
But not gluconase, only glucosides.
Glucosides.
Because immobilization everywhere it is not possible. In each and everywhere it is not possible to immobilize enzyme. Because somewhere some thermodynamic step is involved or high temperature is involved, that the enzyme is going to be activity.
The first question is about the cellulose recovery. I introduced here one technology developed by Professor Roy, and the immobilization may be another way for recovery of cellulose. And do you have some other method to do the recovery?
Yes, it can be entrapped.
For what?
Entrapment method. Entrapment method. Entrap.
Making treatments.
Like we can use sodium alginate to entrap.
Beads, biomembranes.
Oh, by membranes. Yes. Maybe ultrafiltering.
The membranes can be used to restrict to compartmentalize.
Okay. Okay, I mean, if I have another particle, it absorbs the cellulose, the protein, from the solution.
That could be a good idea.
But it's solid.
Yeah.
Yeah. A lot of red
Yeah,
solid.
there are all
The enzymatic process is beneficial only if there is possibility of diffusion of the substrate to the enzyme.
Yes.
Otherwise, there is no use.
Years ago, I purchased a golden nanoparticle. It has a magnetic properties. It can be easily separated from water. I tried. The binding ability of the cellulose components. It has many components. The binding quality is not different.
You need to say cellulose is bound nanoparticle.
Yes, bound to nanoparticle. Especially those
After going through the process, by detonated process,
yes.
you can recollect.
Yeah, it's very needed. Even if it is universal, I had some more water in it. Okay, the separation is not typical. I tried, but I did not publish it.
I think precipitation, we can try precipitating
Precipitation,
just by changing the pH.
change the pH.
It can precipitate. If the pH becomes the same as its isoelectric point, it will precipitate. And but once you bring the pH to normal, it will react. I'm just giving a theory. I didn't try it.
Actually, enzyme can't be precipitate changing the pH. Changing the water content.
No. If the pH is equal to the isoelectric point, it will precipitate.
No, see, when we
This is the
when we run a jet, when we run a jet for PI, the only thing is movement changes. It won't move because of PI. But enzyme, if you change the pH of an enzyme, it will lose the function. That is
Yes.
right. It will lose the function because of change in ionic condition, charge, because of change in charge. But if you want to precipitate enzyme, the only thing is you take out water molecule and water is out of enzyme. Because of water actually a lot of hydrogen bonding takes place. So if you reduce the hydrogen bonding, it will precipitate because water enzymes are active. Because they interact with the substrate with the help of just hydrogen bonding and hydrophobic interactions. So hydrophobic interaction has big role to play for enzyme activity and binding within the substrate.
If we remove the charges present on an enzyme, automatically it won't interact with any water molecule. It will precipitate. That's our proposal, but we didn't try it.
Just discuss.
Yeah.
But as you proposed in the morning only, that just by changing pH 2.5 or 3.5 and using lignin, see enzyme can have some normally it has unproductive binding with the substrate. When we use reverse substrate and we use enzyme for segregation, most of the enzymes they bind with the substrate that is unproductive binding. They bind with lignin or some other substrate. If you use those lignin other compounds for the binding, purposefully binding by changing pH.
Changing pH, yes.
It can bind with the substrate. And then again you take out the substrate and you again change the pH enzyme will leave the substrate. That can be done with matrix also.
Just another idea.
It can be done with matrix also. With matrix. Because if we localize the enzyme at certain pH also, certain pH, certain temperature.
So you have such a vast experience on this cellulosic ethanol and you have been using cellulosic. Sir, can you, from your experience, can you elaborate whether we should go for anaerobic microorganisms or aerobic microorganisms for the production of celluloses? Aerobic or anaerobic microorganisms for cellulose production?
The cellulose production.
Because in many research papers nowadays we are seeing that people are using anaerobic microorganisms. What are the limitations of anaerobic microorganisms for cellulose specifically?
I tried a lot to produce cellulose from
Oh, please absolutely.
They are compatible.
I tried a lot to do production of cellulose from the using sugar micro reducing. You know, I just scale. In China, we produce cellulose. We use only one scale. Okay, it's a Honda, and maybe another stress, which is Niger. As a supplement of other groups like this, we combine them together. I heard from Northern country that they produce a CTEC2 using 9 scales, 9 different scales. They do the fermentation separately and they combine them together. So it's not easy for me to produce a very efficient cellulose like this. And the CTEC2 is different from other cellulose enzymes because it has a very high content of CBH. In China, we have a lot of cellulose suppliers. In that product, the CBH content is very low, usually 10%. 90% is glucose. CBH is very important for the complete dissolution, complete hydrolysis acidification of cellulose, because it works on the crystallized part of cellulose, and it attacks only the amorphous regions. So they're different, and only we use Chinese cellulose, fungal cellulose is not good. But I choose another company. I tried the cellulose from this company, UTLY. You can search it on the website. The boss of this company is a very famous expert in the world. On top of cellulose. They produce the cellulose from fungi, also fungi, but the fungi is anaerobic. It does not need oxygen during the fermentation. It's very special. It's isolated from the stomach of the sheep. It's very special.
This is a Chinese company, Bio?
It's a US company.
US company.
But the boss also has 2 Chinese companies.
Okay.
They share the name UTL.
Okay. And this sensor?
There's a research center in Seattle, in US,
Okay.
not in China. But in China, only production and selling.
Yeah, but their celluloses and xyluloses are very good.
Very good.
Very good. Okay. And now, what will be the cost of 1 kg? Not 1 kg, maybe 1 gram.
For this one, 1 kilogram is solid.
Okay.
18 to 20. 18 to 25. Yes.
How do you decide that 1 kg or 2 kg cost? Because normally what we prefer, we look for is the activity.
Oh, activity.
So if you talk about 1 kg and activity is less,
The activity is like this. In China, in Chinese enzyme suppliers, they do not use FDA. They use CMC.
they don't
They
use
use CMC. CMC activity primarily represents the activity of glucose, not for the CBH, not for the actual glucose.
Suppose we have 2 or 3 enzymes, multiple enzymes, and we have to select one for saccharifycation. What parameter we should take? Like temperature optimum, rate optimum, or Km max catalytic activity. What parameter we should look for? Because the activity
FDA is the most important message.
FDA. Normally we for
I examined the FDA of the FDA is 90 to 100 FDA. Yeah. Its product is not in liquid, it's in a solid form. It's one of the best cellulose in China.
This
And this one, histories are in the two races in the fungal two races. It was first characterized in the two races fermentation cultures by the boss of this company.
So when we use the
They
partially
published the paper 30 years ago.
so partially purified enzyme will be better because you get this history also. Partially purified.
This enzyme, it is added in the culture in the process. The soft, the wood, the big biomass will become soft. And if we use a mechanical defabrication machine, it will sell energy. Nowadays, I use this enzyme combined with enzyme to do the softening of pump freight. In China, some pump freight used for customers.
What ratio do you use all these three to get efficient option? In what ratio all these three enzymes are
What's the
ratio?
ratio? I do not use the activity ratio, I use only the gram ratio.
We just want an idea to make an efficient compound.
Okay. Yes, the glucoside is their ratio. Their ratio is 1 to 1.5. This ratio is activity ratio. But for xylitase, we use 2 to 1. 2 to 1. Yes, that means. Because in my pretreatment, I often use acidic pretreatment. Most of the xylem, at least half of xylem, is degraded by acid. There are a lot of technical problems if we use acidic pretreatment. First, the steel, okay. It should be 304 carbon steel. Mostly we use steel is 302. 304 can stand the dilute sulfuric acid. Tolerate dilute. But the cost is different. This carbon steel is much more expensive. Yes.
Corrosion due to sulfuric acid. 3 or 4 C.
Corrosion, yes. It tolerates the acid corrosion, yes. Do you have some other questions? Any question?
You've explained very well. Now you must be tired also.
So the last one is about the method to get an tolerant to cellulose. You are from the fundamental microbiology. So if you are going to screen a salt tolerant cellulose producing microbe, what should we do?
We are not tracking iron tolerant scale actually because there is beyond our budget. Iron are very costly.
What is the method to get a tolerant cellulase? What is your method? I think we are not using this method. Anybody who is using this method? We are not using. You have to explain us. Okay.
Um, yeah, it's one of my research work in my own lab. Yes, I have a lot of different equipment now. I want to use it to for the publication purpose. So I prepared a cellulose screening substrate mixed with agar and mixed with liquid. But in the first initial step, I do not use liquid. I use salt first, or inorganic salt first. And in the next step, I will use this one for screening. The sample was withdrawn from soil from river, mainly from river, from the salt lakes. I got the samples from delivered the samples to me from 5 males. I also tried to isolate the cellulose producing fungi from black tea. You drink black tea, huh? Dark tea. Dark tea is a fermented tea, right? There is microbial ferments of tea, the tea leaves. And in the tea, there are a lot, high content of phenolic compounds. So it helps me to get the phenolic tolerant cellulose. So I do the cellulose screening like this. I don't know if it works, but I finally I get a strain and I characterize it. I try to do the optimization, but it requires a long time.
Here we use congruent dye to screen these cellulases from soil sample. We use congruent dye. First we take agar media.
Yes.
Then we do serial dilation and we plate it.
Yes.
When we get like astromasis fungi,
Yes.
we do some microscopy.
Yeah.
And then we again take agar plate with xylem.
Yes.
Xylem it's around, you can take 0.5%, 0.5%, 1.5.3% xylem, and then you can make that fungi or enzyme. If you have enzyme, you can make a well and can keep your enzyme.
Yes.
And after some time, keep it for some time, and enzyme is basically which cellulase, it will hydrolyze the xylem. If it's xylanase, if it's cellulose, it will hydrolyze the cellulase. Depends if you want cellulase or xylanase, so any or cellulose. So then you add, then we add congruent dye.
Yeah.
Congruent dye, and it will bind to the portion which is actually the xylem.
If there is cellulose, it will become.
And we get a zone. This is the method we use for normally memory method for screening. This is method for screening. And we want some salt tolerant that we can use as a different concentration of salt.
Yes.
And we can then again integrate with that salt. We can keep different, and we can see the growth pattern.
MC, let's try to collaborate with each other in the future.
Actually, this is so basic that even our MSc students, they are doing this congruent in their practical. They are doing the practical.
So, do you have questions? I welcome any question from you.
So in case you have any questions.
We have spoken a lot.
Yeah.
They should respond.
Yeah.
Not them.
So can anyone of you summarize what was discussed today? Because there was a series of
And
presentations.
one thing I want to bring to you is that myself and Dr. Rajiv, we're asking a lot of questions to our expert. And that some of the questions was purposefully asked. Not because we wanted to, because we wanted that you should also know something, which was very pertinent question. It should come to your mind. That's why we were asking most of the questions. Literally. Because most of the questions that's why we were asking. And now I think they basically ask so that we come to know what biorefinery, what the segregation is. Because for people, these stuff might be very new. Pretreatment, segregation, hydrolysis, and all enzymes name and everything. That's why we ask most of the questions. Now I think it's basic knowledge. You may ask any question, whether it's like silly question or very basic question, because normally what I have felt that a person who is not expert can ask anything, and that can be doable. Because we have like if expert has a very defined thing, and he can speak in between those defined or some whatever experience he or she. But you can ask anything which is because you can ask. It depends on the imagination. So if you have any question, any doubt regarding biodiesel, whatever, related to biodiesel or related to regulatory guidelines. So it could be and myself and Dr. Rajiv, because we have worked in the past month. Recently, we are also working on some enzymes where our expert we have been working on these enzymes. So we can help you if you want to develop some concept on this.
Moreover, for every funding authority, this is always a thrust area. Look at any funding authority, DBT, DST, CSF, one of the thrust area would be biofuels. So in case our students they want to get into it, so it's a good opportunity to at least know the basics about it. So, and if you want to start research in this area, I'm sure it is going to be fruitful. Because many new research groups are entering into the same thing. The people who are working in molecular biology, they are trying to metabolically engineer the microbes so that they can ferment better or they can produce better ethanol. As he spoke about the ethanol tolerance, which is a major hurdle for increasing the concentration because we cannot go beyond 10% of total ethanol concentration. So there is a very good field of research wherein we can increase the tolerance of a particular yeast towards the concentration of ethanol. That's one limitation. The other limitation what we spoke about is the inhibition of the enzyme cellulase. So cellulase has always been a challenge, but when it comes to production, when it comes to the turnover number of the enzyme and the catalytic efficiency. So that's one limiting factor which is actually hindering the commercialization of production of ethanol. So working with cellulases is difficult. Yes, we need to screen more organisms, especially from the rumens of the ruminants. Like he told one company, Sunson, they are isolating or they are producing cellulases from ruminant fungi, yeah, which was isolated from the gut of a sheep. So these are some areas because in sheep you can find the difference in flora and fauna from the sheep in India will be different, and the sheep in China will be different. That we all understand now. So if a project is taken up for studying the total microflora of a ruminant in India, it is going to yield different results. So that is another line of research. Plus, inhibition of cellulases is another challenge which the scientists are facing nowadays. So we can engineer the enzyme in such a way that it doesn't get inhibited, by, especially by the furans and the perfurans, which are produced during the acid hydrolysis. Because nowadays, most of the time we are using acid hydrolysis for the liberation of the hemicellulosic sugars. So if we can get rid of those furans and perfurans, which are the major inhibitors of cellulases, again that is going to be a success for this technology.
And moreover, furans and pencils are also used, it can be used for some other things. So they are actually byproduct. And they can be used like in biorefinery process.
Another challenge which how talked about is the conservation of water. We all know that conservation is water is it's a real issue nowadays. Right? We are heading towards the day zero day, which is the whereas when all the drinking water is going to be finished. So this process, acid hydrolysis, and then neutralizing the hydrolysate, it consumes a lot of water. So that is another challenge that is to be taken care of. Like we should be able to conserve the water. All these processes which are till date used for the production of ethanol actually consume a lot of water. So, and we have to save our water somehow. So I think that's a major challenge. So any other challenges?
I think the last one is how to recover ethanol from the rocks. Lot of lot of molecular seeds that people are using, lot of concentrated process to harness those ethanol from wood rocks. How we can separate the biomass, the isolate biomass from the wood formation rock and other things.
Some answers have come from the membranes, the membrane-based processes. Especially China is very much ahead. I think China supplies a lot of membranes. So many scientists have started feeling that membranes could be very crucial for separation of sugars from the hydrolysis. we have to recover the sugars. And at the same time, membranes can also be used for recovering or for retaining the enzymes. As I told you, the compartmentalization of the enzyme in a membrane. Because membrane sugars can diffuse and enzyme being a larger molecule, it will be retained inside the membrane. So a lot of new innovation is yet to come from the membrane sides.
Can I ask some questions?
Yeah.
So, students, um, has your boss paid about the research work? Anyone give me an answer? Has your boss paid about to your research work? To your reference work in your lab? Have you got the payment? Yes. There's a salary. Fellowship. Okay. Not to swap.
They get fellowship from I think I think we can introduce. We can tell them to introduce themselves. I would like to request the participant to introduce yourself one by one. Any introduction about yourself, place, you belong, and subject you study, and if you're doing PhD or topic, and everything. We'll ask you questions, and we can start from one. Any concept. Yeah. Ready?
Yeah, this should have been done
Yeah,
earlier, but
Yeah.
but
Yeah, actually, the one innovation we skip that one. Yeah. No need to stand, you can sit.
Myself, Dr. Vikas. I'm working as assistant professor in Center for Biotechnology. My teaching experience is about 12 years. And from the past 15 years, I'm working in the field of biosensor technology, basically dealing with the fabrication of working electrode using nanoparticles, different type of nanoparticles, blending them with different type of enzymes.
Hello everyone, myself Dr. Rita Arora. I have done my master's in microbiology from MDU, China. And after that, I have worked as a researcher in the Defense Institute of Higher Altitude Research, which is in Lebanon. And I have worked there for 2 years. And after that, I have worked in National Institute of Bioenergy, which is also in Punjab. And I pursued my PhD over there. And there my topic was on bioethanol production using thermotolerant microorganisms from agricultural waste. And from the last 1 year, I am working as assistant professor in Agri Professional University in Punjab.
Hello everyone, I am GIAN and I am doing my PhD from VIT Mesra, Ranchi. I did my BTech from Amity University and then I completed my MTech from VIT itself and then I worked in Biocon, Bangalore. And my topic of research is it's a polyol production using Indian agro waste. It is a collaboration work of bioinformatics, biotechnology and bioprocess.
of the ecosystem to the student, especially he wanted to know that.
Hello everyone, I'm Kavita and I'm a student of the Masters MSc Microbiology in MDU.
Very good afternoon, and my name is Samriti Krishna, and I did my BSc from University of Delhi, and right now I'm pursuing my MSc in first year from MDU.
Myself, just major from Department of Microbiology MDU. I did MSc from MDU and I did PhD from this institute only, and my field research area is basically in the endocritic diversity of bacteria. That is, I'm working on the diversity of these endocritic microbes from all over the world.
And you also tell that you were in Guangzhou.
Yeah, I
She was in Guangzhou.
No, I was in Fuzhou for 2 years. I stayed in China. It's a place near Shanghai.
Fuzhou.
I can understand whenever he speaks. I can understand the English and comfortably. But otherwise, China is a very beautiful country. You must visit once in your lifetime.
Hello everyone, myself Dr. Anita, working as assistant professor in Department of Microbiology, and I did my MSc and PhD from Kusheka University, and my field of research is bioremediation. Hello everyone, myself Mega Kaushik. I'm pursuing PhD from Microbiology Department. I'm working on detection of antibiotic resistant genes in Escherichia coli.
Hello, my name is Anima Khare. I'm from Water. I'm pursuing PhD in medical microbiology and titled my molecular typing of E. coli strain isolated from Enzymatic water, New Delhi. I'm from microbiology department.
All of you, myself Dr. Gupta. I have done my master's in engineering from Kusheka University. After that, I joined as chair in National Division Institute, Karnal. Then I have done on the project separation of axon by chromosome in OIM. Later, I joined the FMB Yamnagar Big Culture Center, where I have done a lot of research work in paper, like using agriculture dairy product for paper making or production of bioethanol from agriculture.
Hello everyone, I am Babita Sharma. I did my MSc from Department of Microbiology, MDU Rohtak. After MSc, I joined the GST funded project. In that, I was working on plant tissue culture. Recently, I am working in Department of Microbiology and PhD student. My research area is bioremediations of heavy metals. Thank you. Hello, myself Twinkle. I did my MSc from here and you wrote that. After that, I joined PhD under Dr. Pradesh Shukla. And my PhD topic is molecular characterization and enzymatic potential of slow-moving bacteria for the performance of biology.
Hello everyone.
Hello everyone, my name is Mandeep. I have done my master's from the Department of Botany, University of Delhi, and now I am a research fellow in DBT project on the production of fungal elements for cost-effective production of fungal elements for drinking treatment.
Hello everyone, myself Neela. I research scholar in Department of Botany and the University. I am pursuing my PhD in the Department of Botany, and my research topic is role of 5% metal nanocomposite influencing the growth of solar.
Hello everyone, myself is pursuing my PhD from Botany Department and the University. And my research topic is response of the against the metal nanocomposite.
My name is Ali. I did my bachelor's from Kusheka University in Biotechnology, and now I am pursuing master's from MDU Open in Agriculture Biology. Hello everyone, I am Bhanu from Sagar University, and I am working on cellulose and hemicellulose production from AI and their application.
Hello, I'm Dr. Rajiv Kapoor. I'm assistant professor in the Department of Microbiology. And regarding my education, I did my PhD from Delhi University, working on lignocellulosic in the lignocellulosic breakdown lab. And my work was focusing on all the enzymes which are responsible for degradation of lignocellulose. After that, after joining the MDU, I went for my postdoctoral, and there I worked on detoxification of the lignocellulosic hydrolysis.
Hello everyone, I am Dr. K.K. Sharma. I I am assistant professor in Department of Microbiology. I have done my master's and PhD from GIAN and joined this department in 2010. Currently, I am working on two different aspects. One is lignocellulosic enzymes from fungi and bacteria. Another interest is lignocellulosic, not lignocellulosic enzyme, but lactase from arsenic bacteria, like Yersinia. And what role this lactase from Yersinia is playing in culture as well as host, because the process it has some redox imbalancing or a redox balancing effect, and it helps bacteria, protects bacteria from the oxidative rust of the host, and that's why it is known as like it's a slow mechanism. So lactase another has that enzyme which is reported from which is earlier it was reported from fungi, water fungi, it was reported from plants, it is reported from willow moss or bee, it is reported from trees, means lignin, it has a role in lignin synthesis. It has very diverse role. So, the first time we put role of lactase in pathogenicity. So, it is nothing new. And another interest is in IBD and how these enzymes, some of the enzymes play a role in IBD. This is a new interest working on that part. So, this is a very normally thing I work on.
Myself, Pratyush Shukla, I am professor in the Department of Microbiology. I did my PhD from PS University, Masters from Sagar Vishwavidyalaya, MD, India. My interest is in enzyme technology and protein bioinformatics, different aspects including therapeutic proteins as well as industrial proteins. Thank you. I think most of us you have seen, they are students of core hardcore microbiology, and especially we have participants from pulp and paper industry. Yeah, so he is from a big pulp and paper organization here. It is, I think, how far it is? 200 kilometers from here. We can have a visit maybe after we finish. We will see. So we will have a visit to your campus as well. And that is the most ultra modern paper mill, and it is one of the assets for this state. So that is called Yamuna Nagar Paper Mill. And the whole campus is called as Paper Mill Campus, right? Untitled. So we have especially, and other people are also there. You can also introduce Raki your.
Good afternoon, everyone. I'm Raki Thankar, research scholar in the Department of Microbiology here in MDU Water. I'm working on a bacterial enzyme arginine deaminase, and I'm exploring its anti-cancerous potential.
My name is Raki Sharma. I am a student of MSc Microbiology from the department. Good afternoon. Myself Pooja Bohra, and I am a student of MSc Microbiology.
Hello, small. Hello, I'm Dinesh. I'm a student for a department.